Good morning all, my name is Santhosh Kumar, Assistant Professor, Institute of Aeronautical Engineering. My subject is image processing. Today I am discussing about question bank discussion on digital image fundamentals. So what is the need of image processing? Image processing is nothing but we are implementing of pictorial information for human interpretation, for autonomous machine applications, for example in industries, for control and automation, processing of image data for storage, transmission and representation for autonomous machine perception. Processing of digital images by a digital computer is nothing but a digital image processing. Digital images consist of finite elements with particular locations and values. These finite elements are known as picture elements, image elements, pixels. Most commonly, they are calling as pixels. So the question is in the question bank, what is the need of image processing? So what is the need? Means in general, where we are using the image processing, what is the use of that one? Suppose if I am taking any of the image, that image I am taking as a pixels, that is a 3x3 matrix or a 3x3 pixel. So if I am taking this one, it is a 3x3 is equal to 9 pixels are there. So how many pixels are there? 9 pixels are there. So it is the improvement of pictorial information for human interpretation. As per human visual system, how many pixels we need? Suppose I need very less pixels are there. We can't identify the image. So the minimum pixels we need to identify the image. For autonomous machine applications, in example, industries for control and automation. For industrial applications also, controlling and monitoring of this one. For identification purpose also, we need an image. And the processing of image data for storage, transmission and representation for autonomous machine perceptions. So transmitter to receiver, we have to send an image. Okay. So it is also one needful of this one. And in the computers also, digital computers, we are modifying any of the modifications in the original image. It is possible, and it is consist of finite elements with particular locations and values. These finite elements are known as picture elements, image elements, pels, and pixels. In human body, vision is most important or advanced sensors. But the vision is limited to visual band in the EM spectrum. EM spectrum consists of different sources of energies like X-rays, gamma rays, visible band, UV rays, etc. Among all these bands, only visual band is used for visualization of the images. To overcome this disadvantage, the image machines, that means processing systems, are used for image processing to cover entire band of EM spectrum from gamma rays to radio waves. DIP covers wide and varied fields of applications and hence entire spectrum can be considered. So in the human visual system, in the human body, the vision is the most important advanced sensors are there. But in the vision is a limited visual band systems are there. Suppose I am taking the color image, that is a 400 nanometers to 700 nanometers. So every image we have some limited bandwidth or minimum wavelength will be there. Suppose I am taking the X-rays, gamma rays, visual band, UV rays. These are the minimum we need. Among all these bands, only visual bands is used for visualization of the images. So to overcome all the disadvantages in the image processing, the image machine, that is a processing of the systems, are used for image processing to cover entire band of EM spectrum from gamma rays to radio waves. DIP means digital image processing covers wide and variety fields of applications and hence entire spectrum can be considered. So it is about the need of image processing. And the second question is, what is a digital image and how it is works? Means we are defining the image processing here, and how it is works means how it is works from input to output. What is the processing? How it is works? What are the components? What are the stages are there in this? We could discuss now. So image processing is a method to perform some operations on an image in order to get an enhanced image or to extract some useful information from it. And it is a type of signal processing in which input is an image and output may be an image, but characteristics features associated with the image are different. The main objective of the image processing is to transform an image into digital form and perform certain operations on it in order to obtain specific models or to extract useful information from the image. Okay, so it is a method to perform some operations, enhanced image of extracting some useful information from it. So suppose an input image is there, output image also there. So what is the processing is there in between, the extraction is there. So it is a type of signal processing in which input of image and output may be an image, but the characteristic features of the image is there. So the main objective of the image processing is to transform an image in the digital form and perform certain operations on it in order to obtain specific models to extract useful information from the image. That is nothing but a mere data transfer. That is but a in the form of data transfer. So in the data transfer, we have to modify or change or delete. So whatever may be, these are all possible with this one. How it is works means input to output. How it is works. Suppose it is a 3D world around us. Suppose it is my target. It is my target to capture. Okay. So the camera is captured. Camera is nothing but a here sensor. So here is sensor is capturing the image and it is sent to digital image processing system. It is sent to digital image processing. That means a particular system to focus on a water drop. So it's a given its output as processed image. So it is the entire image. In this entire, I need this particular dot only. I need this particular dot means water drop. This water drop is our target. So in this, it is the image. It is a capturing the camera, that is the sensor. After capturing the sensor, the digital image processing system, DIP, is transferred the image that's given into the output as an, that is the output image. But what is happening is in the above, the captured by the camera and has been sent to a digital system to remove all the other details and just to focus on the water drop. By zooming it is such a way that the quality of the image remains the same. So I don't want of all those things. Just I need this one only. I no need of all those things. Just I want to highlight this one. If I'm going to the zoom or if I have to capture this dot in this here. So surroundings I no need of this one. So what is happening means the quality of the image will not be changed. It is same as it is. That is the advantage of digital image processing system. But in the signal processing is a discipline in electrical engineering and in mathematics that deals with analysis and processing of analog and digital signals. Deals with storing, filtering and other operations on signals. These signals include transmission signal, sound or voice signals, image signals and other signals also, etc. Out of all these signals, the field that deals with the type of signals for which the input is an image and the output is also an image is done in image processing, as its name suggests that it deals with the processing of an image. So from the input to output, input is also an image, output is also an image. In between, what is happening? So in this image, digital signal processing is a electrical engineering and is a mathematics that deals with the analysis and the processing of analog and digital signals and deals with storing, filtering and other operations on signals. These signals include transmission signals, sound or voice signals, image signals and other signals, etc. But out of all those signals, the field that deals with the type of signals for which the input is an image and the output is also an image. But between what is the processing is going on, that is the main thing of this one. Okay, the data is transferred. Data transferred. between input and output. So another example is define digital image. It is one question is there. Define digital image. Digital image is nothing but it is a processing deals with developing a digital system that performs operations on an digital image. What is an image? An image is nothing that more than a two-dimensional signal. It is defined by the mathematical function f of x, y, where x and y are the two coordinates horizontally and vertically. The value of f of x, y at any point is gives the pixel value at the point of the image. Okay, what is image? What is a digital image? Okay, so here I'm discussing about what is an image. Here, what is a digital image? Okay, so it is a processing deals with developing a digital system that performs operations on an digital image, and it is nothing but it is a two-dimensional signal. Any of the image I'm taking as a two-dimensional. So x and y, it is defined as a mathematical function f of x, y. So what is the image? Is nothing but it is a f of x, y. F of x, y is the input image, and where x and y are the two coordinates vertically and horizontally. The value of f of x, y at any point gives the pixel value at the point of an image. Here I am taking as a f of x, y equal to what is the image means 3 by 3 is equal to 9 pixels. So what is the size? What is the pixel size of the image? It is f of x, y is the input image. And how we are mentioning the different types of images in that image processing. There are three types of digital image processing. Low level digital image processing, that means input is an image, output is an image, but in that we are using noise reduction. Low level digital image processing. So there are three types of digital image processing. Low level digital image processing, that is one. Input is an image and output is also an image, but in between what is happening means noise reduction. It is the noise reduction. This is using for noise reduction. Another one is a middle level, not a low level, not a high level. It is a middle level. Image is the input is image, output is a out attributes. But what is the this one is a the features are to be extracted and the images are segmented. Okay, and the attributes are nothing but a segments. Okay, the features are to be extracted or images are to be segmented here. Okay, so output is segmented. Here, high level digital image processing. Input is the attributes, output is a making sense. So recognizing an object with values, recognizing a ball using an image. Okay. Here, low level image processing is using for the noise reduction. Here, middle level is using for the attributes. Nothing but we are finding out the segments. Output is a segmented. The features are to be extracted. Images are segmented. And third one is a high level digital image processing. That is nothing but input is an attributes. Here output is an attribute. Here input is an attribute. Output is a making sense. So what is nothing but recognizing an object with values. Suppose I'm taking one object. So we have to recognize. The condition is as per visible. We have to recognizing the image. Recognizing image is an important role here. That is a high level. So recognizing a ball using an image like this. Another question is there. List the basic steps involved in image processing. What are the steps are involved in the image processing? That is important. List the basic steps involved in the image processing. So first one is that the image acquisition, image enhancement, restoration, color image processing, wavelet and multi-resolution, image compression, morphological processing, segmentation, object recognition, and representation and description. How many are there? Total 10 are there. image acquisition, image enhancement, image restoration, color image processing, wavelet and multi-resolution processing, image compression, morphological processing, segmentation, object recognition, representation, and description. So first one, image acquisition. Acquisition is nothing but a, suppose I'm taking one input to output. What is happening means we are forming uh, it is the output adjacent image, it is the image plane, it is the imaging system, illumination of energy. So it is converted into the pixels. So this square, what are the squares are there? Here, these squares are the pixels. Okay, how many pixels means there are number of pixels are there. Here it is an object. It is an object and it is a background. So what is formed here means image acquisition means nothing but a, we are forming pixels to identify the image. Next one is a image enhancement. Image enhancement means it is some white color is covered are there. It from so it is not visible. We are not identifying like this. So okay. So it is this one. We are visibility of the system. Okay. Image enhancement is the nothing but a input to output processing. So image processing. It is nothing but a reduce noise. Image processing is nothing but a reducing the noises or remove blurrings. So remove blurrings and removing the noises. These are all the what are the processes confirmed. Suppose image transformation is going on, Fourier transform, Laplace transform, inverse transform. So what is the processing is going on from input to output? That is the image enhancement. So what is the advantage? It means we are converting to the visibility of the system. That is the image enhancement. Another one is a image restoration. Restoration means suppose f of x f of x equal to g of x and f dash of x. So here f of x equal to input is there, f dash of x output is there. So g of x is nothing but a filters. What are the filters I've used here? So this output is replaced with this one. Output is replaced with input. So that is called the restoration. Why? Because what are the modifications I was performed at the output? That output image is replacing with input image. That is the image restoration. Another one is a morphological. It is some noisy images there. Here noiseless image. So this noiseless image is replaced with noise image. Replaced with noise image. And morphological processing. Morphological processing means what are the noises are there. Suppose here some black color is dominating here. Why? Because it is not recognizing. Sometimes what will happen here, you can observe here we can the background white dots are there. So we have to remove these white dots. So here the background I have to completely convert into the black. Suppose this background is black. Actually the background is black, but white dots are there, but I no need of this one. Why? Because these are the noises are there, and it is black is dominating the finger thumb impression or finger one. So what I have to do means I have to so in this fingerprint black is dominating the white. So that is the reason we are not identifying the thumb. So here also background is black, but the white dot lines are dominating this one. So I have to remove these dot lines of this one. Okay, what I have to do means morphological processings are using to remove the background. So white is replacing to black, black is replacing with white like this. Okay, so morphological processing is nothing but a erosion, dilation, hit or mistransform, and so these are the 5 methods are there. 5 methods of morphological are there. Erosion, dilation, closing, opening, hit or miss. So these are the 5 types are there. So these are the 5 types of morphological processing are there. We are applying here. Okay. Next one is a segmentation. So what is a segmentation means? What are the segments are there? It is one segment. It is one segment. So these segments I'm showing as a this is a small segment. It is a large segment. In the histogram process, we are showing like this. Okay. It is a histogram equalization. So in this graphically in the histogram, what is the segment size width it will be showing here. It is another segment it is showing here. So here as per graphically how many segments are there it is showing like this. These are the segments. How many segments? Any of the image is converting to the segments. It is like an object. Next one is a object recognition. Okay, if any of the image is there, here another image is there. So is there any object? What is object here? The person is the object. So how many objects are there here? Objects equal to 2. How I know means object recognition. Okay, it is a software. How can I'm recognizing the object means? Suppose I have to capture the iris. I have to capture the face. I have to capture the hands. I have to capture the gestures. Okay. So how many? Suppose in the road, I have to capture how many cars are there, how many vehicles are there in the total of 1 minute, and in the particular time, how many vehicles are going on the road and in a particular area. So objects means iris and face recognition. Those are all called object recognition. And representation and description. So how we are representing and descripting that one. Okay, we are showing as a segments samples like this. Okay, so in like this we are showing the representing the image. Next one is a image compression. So image compression is nothing but a suppose input I have 200 MB of data is there. So I have to reduce to 100 MB. Is it possible at output side? Yes, it is output side. It is possible. So 200 MB is converted to 100 MB. What is the process? It is called the compression or not? Yes, it is a compression. So here compression technique is applied for 200 MB to 100 MB, 10 MB like this. It is one example. So image compression is nothing but we are compressing the image. Means we are reducing the size. We are not losing any data. Just we are decreasing the size of the file of the image. That is the image compression. Another is a color image processing. So here some input is there. It is you don't have no colors are there. So we have to apply the color. So apply color is possible. Yes, it is possible to apply the color from input to output. It is a color image processing. Okay, these are the fundamental steps in digital processing: image acquisition, image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description, image compression, color image processing. These are the fundamental steps in digital image processing. Step 1. What is the image acquisition? The modalities for getting the image into the computer. So what is the acquisition? We have to know it is the input to output. What is happening is we are pixels. We are converting to the number of pixels. So image is captured by sensor, which it is a camera, and digitized if the output of the camera is sensed, not already in the digital form, using analog to digital conversion. It is the analog image and it is a digital image. How I know it is a digital means the pixels are there. How many pixels are there? If the pixels are showing, that is the output is a digital. So analog to digital conversion in the image acquisition. Image enhancement, the process of manipulating an image so that the result is more suitable than the original for specific applications. The idea behind enhancement technique is to bring out details that are hidden or simple to highlight certain features of interest in an image. Okay, so identify. So the process of manipulating an image so that the result is more suitable than the original for specific applications. The idea behind enhancement technique is to bring out details that are hidden or simple, to highlight certain features of interest in an image. That is a image enhancement. Next one is a image restoration. Improving the appearance of an image tend to be mathematical or probabilistic model. Enhancement, on the other hand, is based on human subjective preferences regarding what the constitutes of a good enhancement result. Here, it is a noisy image is there. Here, the noiseless image is there. So, it is the output image. It is the input image. So, this noise image, I don't want anything, but I need final this one. So, okay, this output is I'm replacing with this one. Replacing with original image. That is called image restoration. Why? Because what is advantage means if I'm going for the image restoration, I don't need of more space. I don't need of more space occupancy in the memory. That is a good thing. And improving the appearance of the image. Okay, we don't have any confusion. Appearance is important, and the mathematical probabilistic models are there. And other hand, it is based on human subjective preferences regarding what a good enhancement result is there for that one. And the color image processing, it is nothing but we are applying some colors to that one, red, green, blue, like this, primary and secondary colors we have to apply. The image extracting features of interest of an image, color modeling and processing in digital image domain, and multi-resolution analysis using wavelets. At the foundation of representing images in various degrees of resolution, it is used for image data compression, where images are subdivided into smaller regions. Multi-resolution analysis is a different approach of signal processing that gives as the detailed information in the same time. And wavelet transform is an extension of the input signal in the domain that is best suitable for analysis. And wavelet transform gives more information that Fourier transform, and also computationally efficient. So multi-resolution analysis using wavelet. So already we know that wavelengths are there, wavelet transform. So wavelet transform. So in the wavelet transform, we are representing the image in various degrees of resolution. So wavelet transform is for resolutions. And for data compression, where images are subdivided into smaller regions. Actually, wavelet transform are using for one form of image into the another form. Means color image processing, data compression, noiseless image, or whatever may be. So these are the helpful for this one. And the different approaches of signal processing, that the detailed information at the same time, the signals in the domain that are suitable for analysis. And the wavelet gives more information that Fourier transform, and also computationally efficient. Compression. What is the compression? The technique for reducing the storage required to save an image or the bandwidth required to transmit it. Okay, so compression means reduce the size of the image, but no data can be lost. So the technique is for reducing the storage required to save an image on the bandwidth required for transmit, but no need of any no data can be lost. Only the size of the image should be lost for the saving of image, saving of memory. And what are the one question is there? What are the components of image processing? So in the image components means first I need a image sensor, specialized image processing hardware, computer, image display, hard copy, mass storage, image processing software. So these are the components of an image processing. First one, problem domain. First one taking as a input as a image sensor. It is nothing but a image sensor is nothing but a camera. So the camera is captured one image. That is that specialized image processing hardware. This one, what is happening? Analog to digital or digital to analog is converting. Suppose I need a hard copy means hard copy is a digital or analog or not? Yes, the digital to analog conversion is there. But I need an image display. That means analog to digital conversion. So analog to digital for image display. Digital to analog means some hard copy. So in this specialized image processing, the A to D and D to A conversions will be there. After then it is added to the computer. So computer there are so many options are there. Computer have to show the image display. It is the first thing, and it is storing the image. That is the second thing, and processing of software means reduce size, and reduce noise like this. So there are so many options are there. So image sensor, specialized image processing, computer will show the image display or mass storage for storing the images, and image processing software, and these are the hardware series there. These are the components of an image processing system. Image sensor. What is image sensor? Two elements are required to acquire digital images. The first is the physical device that is sensitive to the energy radiated by the object we wish to image is a sensor. It is nothing but a camera to capturing. Camera is nothing but a analog to digital. Analog is object, digital is converting to the image. Okay, analog is nothing but a object. Digital is nothing but a digital image. So the second is called a digitizer. Is a device for converting the output of the physical sensing device into the digital form. So analog to digital. Object is converting to the digital image. Specialized image processing hardware. Usually it is consist of digitizer mentioned before, hardware that performs other primitive operations such as arithmetic logic unit, which performs arithmetic and logic operations in parallel on entire images. This type of hardware sometimes is called a front-end subsystem, and the most distinguished characteristics is speed. In other words, this unit performs functions that require faster data throughput that the typical mainframe computer cannot be handled. So, specialized image processing hardware. Hardware is nothing but we are storing the images, or we are converting the images. Image processing software. So software is a must for image compression and restoration like this. Image processing consists of specialized modules that perform specific tasks. A well-designed package also include the capability for the user to write code as a minimum and utilizes the specialized modules. And mass storage capability. Mass storage capability is a must in image processing applications. The 1024 into 1024 pixels require 1 megabyte of storage space if the image is not compressed. The digital storage for image processing applications are into three principal categories: short-term storage, online storage, archival storage. So these are the three types of storing the images. Okay, first one is a mass storage capability, means store the in the hard disk. So it is a capability of must of image processing. There is example in 1024 to 1024. It is a megabyte of memory I need. So it is storing in a memory. And there are three principal categories of memories are there: short-term storage, online storage, archival storage. Short-term means during the processing, means we are converting from analog to digital conversion during the process, and it is a relatively fast recall. Recall means in the online, okay, online only. We have some database will be there. Database is maintaining, okay, and third one is a archival storage, means memory is needed in a computer or pen drive, magnetic disk, magnetic tape, So these are the archival storages of this one. And mass storage capability. One method of providing short-term storage is a computer memory. Another is by specialized boards called frame buffer and that store one or more images and can be accessed rapidly. The online storage method allows virtually instantaneous image zooming as well as scrolling, and the pawn horizontal online storage generally takes the form of magnetic disk and magnetic optical media storage. The key factor characteristics of online storage is frequent access to the stored. Finally, archival storage is characterized by massive storage requirements but infrequent need of access. Image display, where we are showing the image means in the TV monitor or computer or in the sensor, it is in the mobile, or graphically we are showing of the any card. So these are that. But the display is used to mainly color, preferably flat screen, TV monitor, black and white or color, and graphic display cards that are an integral part of computer system. Hard copies nothing but used for recording images, include a laser printer, film camera, heat sensitive devices, inkjet units, and digital units such as optical and CD-ROM disks. These are the image displays. Another reason, networking is almost a default function in any computer system in use today because of the large amount of data inherent in image processing applications. The key consideration in image transmission is the bandwidth of this image. The dedicated network, this typically is not a problem for communication with remote sites via internet, not always for inefficient networking for image storage. So these are the references. So this is about the components of an image. So in the question bank, we discussed what is the need of image, what is the digital image, and how it is works. It is a process of working. And define digital image processing. Define definition of image and definition of image processing and definition of digital image processing. These are the types of digital images: low level, middle level, and high level. So these are the list of basic steps involved in image processing. First one is a image acquisition, image enhancement, image restoration, morphological processing, segmentation, object recognition, representation and description, image compression, color image processing. These are the digital image fundamentals: image acquisition, image enhancement. These are the diagram of image restoration, color image processing, multi-resolution analysis. Means wavelet transform, Fourier transform is using here. Compressing means we are reducing the size of the original image and the replacing with restoration technique with restoring that one. It is the components of image processing: image sensor, specialized image processing, computer, image display, image processing software, mass storage, image display, networking. So these are the components of image processing. Okay, thank you.
Like, share and subscribe. Hit the bell icon for more updates.